where is it? E to the negative x sine x on the interval 0 to pi. Okay, so first let's get the derivative. Okay, let's get that out of the way. Now this really should be something that you don't even think about anymore. Finding derivatives has to be so automatic that it's honestly you don't think about it. Okay, so I have to use product rule. So f prime g. So f prime is e to the negative x times -1 by chain rule times sine x plus f g prime. So cosine x. So good, we're all done with the derivative. And then since we're going to have to deal with setting this equal to 0 and all that stuff, let's actually factor out the e to the negative x. So this is e to the negative x times cosine x minus sine x. And that's it. That's our derivative. Cool. Now let's look at the critical numbers. Again, two types, right? So let's okay. So two types. Where does the derivative not exist? Where does the derivative equal to 0? So where does the derivative not exist? Well, none. Again, we've gotten a lot of nones here. So let's just remind ourselves, how can you get an answer that's not none? You should be on the lookout for absolute value and exponents that are less than 1, right? Remember that we said that earlier in the lecture. But we haven't really had that again since that second example. Where does this thing equal to 0? Now, remember, what is nice about e to anything? When you're solving equations like this, when you have e to the x or e to the whatever as a factor and the whole thing equals 0, what is nice about this? Can someone remind us a nice property of e to whatever that kind of helps us out here? It's right, it can't equal 0. Exactly. E to anything is always actually positive. So I can actually cancel that out of the equation, right? I can just kind of divide both sides by e to the negative x. It's never equal to 0. Okay, so we just get, so I will kind of make a comment there, right? Always positive. So it cancels out. And we're left with solving the equation, just cosine of x minus sine of x equals 0 on the interval 0 to 2 pi. Now, how do you actually solve this? Well, there's a few ways we can do it. It's probably easiest just to look at the unit circle. Please. Okay. So this is the same thing as saying what? This is the same thing as saying cosine of x equals sine of x. Now keep in mind when you actually have, can we just say pi over 4 because both values of cosine and sine are equal? Well, that's one of the solutions, pi over 4. So another good way you can see this is, so there are other solutions to this equation other than pi over 4. So I like to think about it this way. The cosine of the angle is the x coordinate. The sine of the angle is the y coordinate. So this is essentially saying that the x coordinate and y coordinate have to be equal on the unit circle. So I'm looking for the intersection of the diagonal line y equals x with the unit circle. Right, so you can actually see there's going to be two possible angles. There's going to be pi over 4, and then there's going to be this other angle, which is diametrically opposed, right? It's its antipode, so 5 pi over 4. You can also think of it in terms of reference angles, right? Once you know that pi over 4 is a solution, you can get all of the other ones by thinking about reference angles. Where is the tangent positive or negative, right? Because this is equivalent to saying that the tangent of x is equal to 1, and the tangent of x is positive in the third quadrant, right? So there's a few ways you can go about solving it. All right, now we make our table of values, right? Because we're done with the critical numbers. Okay, so what x values do we need? So first of all, I need my critical numbers, pi over 4 and 5 pi over 4. And then I need my endpoints, which were 0 and 2 pi. And I substitute those back into the original function, which was e to the negative x sine of x. And again, we're not using a calculator here. So pi over 4 gives me e to the negative pi over 4 times 1 over root 2, right? Sine of pi over 4 is 1 over root 2. What is the sine of 5 pi over 4? So I get here e to the negative 5 pi over 4 times the sine of 5 pi over 4. And what is the sine of 5 pi over 4? Negative 1 over root 2. That's correct. Right, because it's in the third quadrant, and only the tangent is positive there. Now 0 gives me obviously 0, and 2 pi gives me 0, right? Because sine of x is 0 at 0 and 2 pi. So I get 0 for both of those. Now you don't need a calculator to figure out which is the least and which is the greatest, right? Because I have 0 and 0, and then I have a positive number and a negative number. So very clearly the negative number is the min, and the positive number is the max, right? So you don't need a calculator to actually figure this out. So the absolute min is negative e to the negative 5 pi over 4 all over root 2. And the absolute max is e to the negative pi over 4 over root 2. Nice.